So today I will talk about angle modulation. Consider angle modulation. Angle modulation comes under frequency and phase modulation, commonly called as angle modulation. See, in angle modulation, consider a wave. This is the general representation of an angle modulation. V of t, that is Vc of t is equal to Vc cos omega ct plus phi c. So omega ct plus phi c represent the angle of the carrier. Okay, so there are two ways of varying the angle of a carrier. By varying the frequency omega c, then it is called frequency modulation. By varying the phase phi c, then it is called phase modulation. So this is the general expression for angle modulation. If you vary this omega c, then it becomes frequency modulation. If you vary this phi c, then it becomes phase modulation. So this is the general expression for angle modulation. Now our area of interest is frequency modulation. So this is the fourth chapter. So in frequency modulation, you know what is the frequency modulation. So this is the message and this is the carrier. Okay, so in frequency modulation, frequency of the carrier is varied in accordance with the amplitude of the message signal. See, listen here, the amplitude is increasing, so the carrier frequency is increased at this range. So this is the modulated signal, this is the message, this is the carrier, this is the modulated FM. So look at here, as the amplitude increases, frequency of this carrier is increased here. Now look at here, this is the FM modulated wave. So in FM modulated wave, as the amplitude increases, frequency is increasing. As the amplitude decreases, what happens to the carrier frequency? Carrier frequency is decreasing. Here again amplitude increasing, so carrier frequency is increasing. So there are two types of frequency here, high frequency, again a low frequency, again a high frequency, again a very low frequency, like that. So in frequency modulation, frequency of before modulation carrier have a single frequency, but after modulation, look at here the frequency is varying in accordance to the amplitude of this message. So in FM, frequency is continuously varying in accordance with the amplitude of the message. So this is what is called a frequency modulation. So mathematical representation of FM, it is like this: F equal to Fc into 1 plus k Vm cos omega m into t. Instantaneous frequency of FM wave. This F is the instantaneous frequency of FM wave. So FM wave can be represented by V equal to Vc sin theta. Okay, so what is theta here? This is another question. For FM can be represented as V equal to Vc sin theta, and theta can be represented as integral omega dt. What is omega? See, F is nothing but omega only, omega by 2 pi is F only. By 2 pi you can make this F as omega. Why? Because just putting omega by 2 pi, F become omega. Okay, so that 2 pi cancel, here become omega. So that's why I am taking this as omega, this as omega c. So theta equal to integral omega dt. So this is omega is this. So substitute the value of this omega here. F is nothing but omega only, so you can put this value to here. So Fc become omega c into 1 plus kvm cos omega m into t. Now integrate these two times, integral omega c dt plus integral kvm cos omega m into omega c into t into dt. So this integrate you will get omega ct, this integrate you will get sin, cos integrate you will get sin by omega m, sin omega mt by omega m, that you can take outside. So it is constant kvm omega c into integral cos omega mt. Integral cos omega mt is sin omega mt by omega m, that omega m I am taking here. So it is like this. So this is omega ct plus kvm fc by fm into sin omega m into t. So omega ct plus this kvm fc is called delta f. This delta f is called a frequency deviation, and delta, so this can be replaced by delta f by fm sin omega m into t. So this is the value for theta. You got the value of theta as like this. Now substitute the value of theta in this equation, then you will get v equal to Vc sin theta. You find the value of theta like this. Substitute the value of theta to this equation you will get V. So substitute the value of theta here. You will get V equal to Vc sin theta. Theta is nothing but this only. So Vc omega c t plus delta f by fm sin omega mt. So delta f by fm is called a modulation index of fm. Okay. Modulation index of fm. In fm, modulation index is delta f by fm. It is represented by beta or mf. In some textbook it is written it is represented by beta. In some textbook it is represented by mf. Both are right, so you can choose either of this. So delta f is called a maximum delta f is frequency deviation. Delta f maximum is maximum frequency deviation. So we know that f equal to fc into 1 plus kvm cos omega m into t. So f equal to fc plus kvm fc cos omega m into t. Take this fc inside. Frequency deviation here, delta f is delta f. This is actually the general equation. No, this is our derived equation. We comparing this with the general equation. So f equal to fc plus kvm fc cos omega m into t. This one. This is the general equation. F plus f equal to fc plus delta f. No, we know that f is nothing but this is another equation. F equal to fc plus delta f. Delta f means nothing but frequency deviation. That is how it is deviated from the carrier frequency. To what extent it is deviating from the carrier frequency. See, in frequency modulation, what is the basic idea? When you give a voltage, corresponding frequency should be generated. That means your message amplitude is increasing, corresponding frequency should increase. If the message amplitude decreases, the frequency should decrease. That means there is a voltage to frequency converter only. No, actually, as the amplitude of message increase means what? Voltage is increasing. At that time, your frequency should increase. As the amplitude decreases, your frequency should decrease. That means when voltage increases, frequency should increase. When voltage decreases, frequency should decrease. That is actually a voltage to frequency converter. And to what extent that frequency is changing, and that is represented by delta f. That is frequency deviation. And it's from here, comparing these two, you will get delta f equal to kvm fc cos omega m into t. What is the maximum value of delta f? Delta f maximum, when cos omega this term become 1, it will become maximum. So a delta f maximum is plus or minus kvm fc. Okay. So that's about it. So this is the general equation for fm. V equal to Vc sin of omega Ct. So this is the equation we know. So this delta f by fm you can put it as beta. So this same equation I am writing. V equal to Vc sin omega Ct plus beta sin omega m t. See, Vc sin omega Ct plus beta sin omega m into t. So this beta or mf is normally called modulation index. Okay. Modulation index beta equal to delta f by fm. That means it is directly proportional to delta f and inversely proportional to fm. Of course, you can use beta or mf whichever way you want. So these are the two kind of representation. So this is about the mathematical representation derivation of fm. So next is frequency spectrum, that we will discuss in next class.